Hola chiquitas, so we out here doing number 6 for the chapter 13 homework, and it says that an archer must exert a force of 375 newtons on the bowstring shown in figure P13.6a, but I drew figures for you already so you don't have to flip and go through all that trouble. Anyways, such that the string makes an angle of theta 35 degrees with the vertical. A, determine the tension in the bowstring, and B, if the applied force is replaced by a stretched spring, as in figure P13.6b. I also drew that for you. And the spring is stretched 30.0 centimeters from its unstretched length. What is the spring constant? So first, they ask us for the tension in the string. So I drew out the diagram here, and I drew out all of our needed things in the diagram, and I made this upward directions my positive y, and then this direction here my positive x. So we are given a force of 375 newtons, and that the bowstring makes a 35-degree angle with the vertical, so therefore we know that this angle on the inside here is 55 degrees. And algebra, so we know that this part here is cosine and this part here would be sine. So solving for t, we can use our sum of forces. So we know F is equal to ma, but we can set that equal to 0. And since this is my positive x direction, we know that this is my negative x direction, so it would be F minus 2t cosine 55. And again, because right here is cosine, we use cosine, and we set that equal to 0. And more algebra, you can bring this over to this side and make it F equals to 2t cosine 55. And solving for t, we change up the equation and get F over 2 cosine 55. And we plug the F that we were given, and plugging it into your calculator, you should get 326.90 newtons. And for B, they tell us that the force is replaced by a spring right here, and it's stretched 30 centimeters, which is equal to 0.3 meters. So using Hooke's law, we know F of the force of the spring equals negative kx. We can solve for k by changing up the equation and plugging in the force they already gave us and putting it over the x value that they just gave us, 0.3 meters. You should get 1,250 Newton meters. Thank you for listening. Bye.